Hi class, this is lesson 4.8. Use the quadratic formula and the discriminant. So the quadratic formula is definitely, again, something you've seen before. Yay, something that should be pretty easy to remember. So the quadratic formula, let a, b, and c be real numbers such that a is not equal to 0. The solutions of the quadratic equation, ax squared plus bx are plus c are this. So this is how we find them. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And if you Google this or go on YouTube, you can find tons of songs to help you remember this. If you look up the quadratic formula, I would sing one. I know some, but you don't want me to sing for you. So here's our quadratic formula. And you have to remember, it's when we know this, when we have a quadratic, that's what must be given. And big thing here, your equation must be equal to 0. Okay, your equation absolutely must be equal to 0. I'm going to put this around that so you remember, but you must have your equation equal to 0. Okay, must. Have I said must enough? All right, so example 1, solve an equation with 2 real solutions. So we will be showing and talking about how you can tell how many solutions there are, because it's pretty easy to see. So for this one, I know that a equals 1, b equals 7, and c equals -6. Those a and b are my coefficients. C is my constant, and it's equal to 0, so I know those are right. So x equals, set up our quadratic formula, the opposite of b, so -7, plus or minus the square root of b squared, 7 squared, minus 4 times a times c, all over 2 times a. Now, when you simplify this, you should always simplify what's under the radical sign first. So x equals the opposite of 7 plus or minus, and this is all going to be over 2. And I've got the square root of 7 squared is 49, minus 4 times 1 times -6 is -24. So I have x equals plus or -7 plus or minus the square root of 73. Now since that 73 is positive, we know there's a positive square root and a negative square root. So this is why this one has 2 possible solutions. And this is still divided by 2. Now the square root of 73, if you could break that down and reduce it as a radical, you need to do that. We can't, so we keep the square root of 73. So our 2 solutions are this. X equals -7 plus the square root of 73, all divided by 2. And x equals -7 minus the square root of 73, all divided by 2. There are my 2 solutions. There are 2 solutions exactly, so if my square root is positive, like I have a positive 73, if it's positive, I am going to have 2 solutions every single time. So now let's solve one when we have 1 real solution. So this next problem will only have 1 real solution to it. So solve an equation with 1 real solution. The first thing I noticed right off the bat, before I do anything, I got a -8 over here. And I told you have to have this side equal to 0. So we have to start by moving that. So I'll add 8 to both sides. So I have 2x squared minus 8x plus 8 equals 0. Now I have 0 over on the right side. And you guys might be thinking, why in the world are we doing another way of solving quadratic equations? We have so many ways. Well, this quadratic formula works all the time for solving all equations. Factoring, doing perfect squares, things like that, they only work part of the time, depending on what your equation looks like. We can't factor every single quadratic, but this works all the time. That's why we need this method as well. Okay, so we've got it in standard form now. We've got it set equal to 0, so a is 2, b is negative 8, and C is positive 8. So let's fill in our quadratic formula. So it's x equals the opposite of b, so that becomes positive 8, plus or minus the square root of b squared, so negative 8 squared, minus 4 times a is 2 times c is 8, all over 2 times a, so 2 times 2. So simplifying, as I said before, you simplify under the radical first all the time. So we have 8 plus or minus the square root. Negative 8 squared is positive 64. Minus 4 times 2 is 8 is 64. And that's all over 2 times a. 2 times 2 is 4. So this is x equals 8 plus or minus the square root. 64 minus 64 is 0, all over 4. Now, think about it. The square root of 0, it's just 0. 8 plus 0 is 8. 8 minus 0 is 8. So my two solutions really just go away. I only have 1 because I only have one square root there. So it's really just 8 over 4, which is 2. So x equals 2 is my solution. So if when I take the square root, I have a positive square root that I'm taking, I have two solutions. If I have 0 under my square root, I only have one solution. Now let's look at one with an imaginary solution. So on the right side I have a 5. I can't have that. I have to have 0 over there. So I'm going to start by subtracting 5 from both sides. So I have the opposite of x squared plus 2x minus 5 equals 0. So a here is negative 1, b is 2, and c is negative 5. So x equals the opposite of b, so negative 2, plus or minus the square root of b squared, so 2 squared minus 4 times a is negative 1, times c is negative 5, and that's all over 2 times a, so 2 times negative 1. So x equals negative 2 plus or minus the square root. Let's simplify underneath that radical first. 2 squared is 4, minus 4 times negative 1 times negative 5 is a negative 20. Actually, it's positive 20, not negative 20. And that's all over 2 times negative 1 is negative 2. So x equals negative 2 plus or minus the square root. 4 minus 20 is negative 16. Not negative 16. 4 minus 20 is negative, yes it is negative 16. All over negative 2. So simplifying this, if I do, and I'm just questioning here because my answer key looks a little bit different, but I think the answer key in this case is wrong. I think I'm doing it right. So I'm just going to double check my work here for a second. This is what you should do if something doesn't look right. 2 squared is 4. Got my minus sign moved down here. 4 times negative 1 is negative 4. Negative 4 times negative 5 is positive 20. 4 minus 20 is negative 16. Yeah, I did that right. Okay. I am right in this case here. So let's simplify this. And if you look right here, that's a negative number. With that being a negative under the radical sign, we know we have to use an imaginary number. So we take the I on the outside to take care of that negative. And then we'll do the square root of 16, which is 4. So I times 4, but we're not going to write it in that order. We're going to write 4I. So this simplifies to x equals negative 2 plus or minus 4I all over negative 2. Now, one thing I notice right away is that I have a bunch of 2's and 4's. Look at these numbers right here. Those two reduce, and these two reduce. Okay, since negative 2 goes into both of those coefficients, I need to simplify this. So x equals negative 2 divided by negative 2 is positive 1, plus or minus 4 divided by negative 2 is negative 2, but really that sign is taken care of by the plus or negative minus sign, so it's just plus 2I. And that is my answer. Sounds like I've got a timer going off somewhere, so I'm going to have to pause this and come right back. Okay, we're taking care of on the home front here. So this is my final answer right here. X equals 1 plus or minus 2i. Let's look at the other side of our notes. All right, so our checkpoint here, we're going to use the quadratic formula to solve the equation. You should pause this and try this one. Oh, well, we haven't solved one quite like this. Actually, let's do this together. Okay, so we don't have 0 here. We're going to add 16 to both sides. So I have 2x squared plus 12x plus 16 equals 0. So I've got set equal to 0. I can find my a, b, and c now. A is 2. B is 12. And c is 16. Let's use our quadratic formula now. X equals the opposite of b, so negative 12, plus or minus the square root. B squared, so that's 12 squared minus 4 times a is 2 times c is 16. All over 2 times a, which is 2. So x equals negative 12 plus or minus the square root. We're going to simplify the radical first. 12 squared is 144. Minus 4 times 2 times 16 is 128. All over 2 times 2 is 4. So x equals negative 12 plus or minus the square root. 144 minus 128 is positive 16, all over 4. Now square root of 16, that's 4, that's exact, so we can simplify it. So x equals negative 12 plus or minus 4 over 4. Now we can simplify this. We can split it up into 2. Since we've got all numbers now, no radicals left over, we can say x equals negative 12 plus 4 divided by 4, and x equals negative 12 minus 4 divided by 4. So negative 12 plus 4, well, that is negative 8. Negative 8 divided by, yep, that's negative 8. Negative 8 divided by 4 is negative 2. So x equals negative 2. Or x equals negative 12 minus 4 is negative 16. Negative 16 divided by 4 is negative 4. So there are my 2 solutions. All right, let's talk about using the discriminant now. So as we've gone along here, I've talked about looking at what's under the radical sign. If it's positive, we're going to have 2 solutions. If it's exactly 0, so I take the square root of 0, it's always 0. There's going to be just 1 solution. And if there is a negative number under the radical, there's going to be 2 imaginary solutions. So that piece under the radical, the b squared minus 4ac, that is what we call the discriminant. Okay, so let's fill in the rest of these notes here. Let's talk about our discriminant. I'm going to move my slide up a little bit here. Okay, so when using the discriminant of ax squared plus bx plus c equals 0, if b squared minus 4ac is greater than 0, the equation has 2 real solutions. The graph has 2 x-intercepts. So wherever your solutions are, that's where it crosses your x-axis. When b squared minus 4ac equals 0, the equation has 1 real solution. And the graph has 1 x-intercept. When b squared minus 4ac is less than 0, the equation has 2 imaginary solutions. And then the graph has 0 x-intercept, so it does not cross the x-axis at all. So let's use our discriminant here. All right, so for each of these, for A, B, and C, we want to find our discriminant and then say how many solutions there are. So for A here, A equals 1, B equals 6, and C equals 5. So B squared would be 6 squared minus 4 times A is 1 times 5 is C. So that's 36 minus 20. which is positive 16. And since it's positive, we know we have 2 real solutions. The next one, for B, well, A equals 1, B equals 6, and C equals 9. So B squared would be 6 squared minus 4 times A times C, which is 9. So that's 36. 6 squared is 36 minus 4 times 1 times 9. Well, that's 36. 36 minus 36 is 0. So that tells us there is 1 real solution. And then the last one for C, A equals 1, B equals 6, and C equals 13. So I've got 6 squared minus 4 times A is 1 times C is 13. So 6 squared minus 4 times 1 times 13 gives you negative 16. Since that's a negative number, we know we have 2 imaginary solutions. All right, this is the end to this lesson. Lesson 4.8. Please make sure if there's anything that didn't make sense, you star it so we can talk about it in class tomorrow, and have a wonderful day.